Hi, everyone. We are right at 12 o'clock, so we're going to get started. Welcome to the first event of the Making Soils Data Actionable webinar series. I'm Danny Gilardi, Senior Soil Scientist at the Washington State Department of Agriculture, and I'm very excited to welcome you all today to talk about soils data. Working in this space, you have probably noticed that more soil tests and more soil data are available to farmers than ever. And while this can be empowering, it can also be really confusing. New information on soil chemistry and biology and physics can sometimes be difficult to translate into action on our farms. And so the Washington Soil Health Initiative has put together this series to showcase how useful and necessary soils data can be to making in-field decisions. Every Wednesday at noon for the next month, we will be showcasing projects from across Washington State that are using real data to make real-world on-farm decisions. And today we have Adam Peterson here to help us understand how Thurston Conservation District is making soil chemical indicators actionable. Adam serves as the Senior GIS Science Specialist at Thurston Conservation District, and since 2020, he has spearheaded Thurston CD's Soil Health Program, overseeing the generation of hundreds of soil test interpretive reports for cooperators in Thurston County. Adam holds an MGIS in Sustainable Management from the University of Washington and an MS in Crop Science from WSU. And so for everyone in the audience, there will be a Q&A at the end, but feel free to post your chats into the chat feature as we go. Molly and I will be moderating that. And you can find the chat feature at the sort of right hand of your Zoom screen. And so thanks for being here today, Adam. Feel free to take it away.
Awesome. Thank you, Danny. And thank you for attending my presentation today on making soils data actionable. So I wanted to start off with a little bit about myself. I think I might be kind of repeating some of the stuff that was just mentioned, but I'm the Senior GIS and Science Specialist at Thurston Conservation District. I do a lot of different things in my role, from GIS work to drone work to irrigation water management, but soils is a big one and one we'll be focusing on today. I kind of have an interesting background. So I started off in crop science, where I started at Evergreen, and then later at WSU, where I did my graduate research, where I focused on domestic production of quinoa. And then I later kind of migrated into GIS work. I found myself self-teaching myself GIS skills to review climate suitability for quinoa, and ended up going back to school to really dive into GIS. And so ever since, I've kind of found myself in this fascinating and fun overlap of agricultural and technology. And I'll be showing some kind of examples of how I've drawn on both those backgrounds for Thurston CD soil testing program. So my talk today is focused towards technical service providers. I'm a technical service provider, and many of you here today might be as well. I'm guessing many of you are already familiar with conservation districts, but I just want to give a quick moment to go over TCD, what it is and what it does. Thurston CD, like all conservation districts, is a non-regulatory agency that acts to serve the public towards conservation goals. There's approximately one per county. And so if you live in Washington State, you very likely have a conservation district that you can go to as a resource. So throughout my talk, I'll be talking from the perspective of a TSP in Western Washington. And so I just want to acknowledge that a lot of what I have to say will come from that perspective. I hope that whether you're working with small urban gardeners or wheat farmers farming 1,000 acres or more, that some of what I cover today will be relevant and useful. So I'd like to dive into Thurston CD soil testing program and a little bit about our context and approach. We're somewhat unique in that we're open to all members of the public. We currently process about 200 to 240 soil samples a year. We send out about as many interpretive results, reports of the results. And many people submit more than one. So we probably reach around 110 to 130 cooperators a year. Thurston County is really unique in that we serve a diverse mix of producers at all scales. We have ranches that are hundreds of acres in size, and there are backyard gardeners with single raised beds that test with us. So we're working from large acreages to 10 foot by 10 foot raised beds. It really makes it fun and never boring. We work with a diversity of producers, diversity of soils. The glacier stopped halfway through Thurston, so we have both glaciated and unglaciated soils, and there's fun management consequences and needs for those. So there's never a boring day. I'll be talking about some of the ways we've been able to serve everyone in the county in that diverse mix of folks, no matter what their scale, in an efficient and timely way. So the key of my presentation today is the main question of the series. How do we go from what we see here on the screen, a kind of a set of soil test results, to this, actual on the ground practice of nutrient management? And one common approach to soil testing is to provide a cooperator with the results and then an extension publication that will help them interpret the results. And kind of what I'm showing here is a common approach. So you have your results here on the left, and then maybe a soil test interpretation guide. This one here is a great one from Oregon State University. Or sometimes there might be a crop specific one that's specific to your particular production area. And with this approach, you're really going through each nutrient and you're looking at tables and seeing, hey, is my potassium level, how does that compare to this recommendation? How much would I need to put on if I do need to put on any? And so, once you've done that for every nutrient that there's information on, the next step is to translate it into application rates. And so I'm going to kind of walk you through that process of what that looks like. So in this case, let's just assume that we're working with an organic, diversified veggie farm here, and they're asking for fertilizer rates on a per 1,000 square feet basis. So we'll start off with phosphorus, and let's assume we need 80 pounds of phosphate per acre. We're going to have to translate that into square feet because we're going to get to 1,000 square feet. Then kind of one of the main go-tos and more available fertilizers is bone meal. That's 17% phosphate phosphorus. So we account for that and then multiply it by 100,000 square feet. Gets us about 10.8 pounds of bone meal. But bone meal also contains nitrogen. So now we have to do some math to account for the nitrogen contribution of bone meal. And then let's say now we're looking at nitrogen and we definitely need some of that. We want to adjust the amount of nitrogen we put on downward from our phosphorus fertilizer and do the same math again. And this is something that you would repeat for any nutrient that's low. If you're still with me, I want to say something about this approach. I think it works for certain folks really well. Many people love doing this. I'm one of them. I love a piece of scratch paper and unit multipliers. But in many ways, it's really a form of accounting. And some people do prefer this approach. They just ask for the results only, and they do this on their own. However, I'm not sure this is the most accessible approach for everyone. And so I want to bring this back to one of the main questions of the series is how do we make soils data actionable? For me, and I think for our program, it's by translating this data into easy to implement actions. To borrow the motto from the recent SoilCon that I participated in, we're providing diverse solutions for diverse soils and diverse cooperator contexts. So my approach is to kind of be as clear as possible and do as much work for the cooperator as you can. Here's a screenshot of one of the key sections of one of our interpretive reports. We break it down column by column. In the first column, we see a locally common and available fertilizer. We explain what the nutrient or nutrients are that fertilizer supplies. And then we provide key information of how much of that nutrient is needed in the third column. And then on the last column, really importantly, and sometimes this is a little hard to come by, but we explain what the best way for them to apply it is and how to apply it. I want to talk a little bit about our role in that process. So the soil testing itself, while it used to be done in the past at the district, is now done by outside labs. So like many conservation districts, we're sending these off in bulk to outside labs. Our role is really one of interpreting the results in a meaningful and accessible way. So how do we do that? And what recommendations, what guidelines are we following? And everything we do, we want to find an approach that's locally appropriate, and we want to be crop specific too. There are some very large differences between crop types. We do a lot of them, as you'll see on the next slide. The primary guidance for us has and always will be land grant university guidance. We turn to WSU primarily, as well as Oregon State University. For some more niche crops, we might go a bit further afield. Things like, we get requests for things like pawpaws, going to the Midwest for that. And so we want to make sure that we're always basing our work on this land grant university guidance. And then we always want to take into account past practice results and experiences. We have people who've been testing with us for over 10 years. And so being able to go back and see their journey of their soil and soil testing results and their nutrient management over time can be really informative as well. And then last but not least, I always have my trusty copy of Radian Wheel, the Quintessential Soils text, The Nature and Properties of Soil, by my side, which has been really handy and kind of helpful at some key moments when I'm a bit stumped at what I'm seeing. So we've asked a number of questions to make sure the recommendations that we're providing meet the management preferences of the producer, whether that's the organic or conventional, the scale, whether that's on the backyard scale or per acre, and the crop type. You can see in the center the many options we offer here, anything from vegetables, cut flowers, pasture, fruit trees, blueberries, lawns. Those are probably our most common. But things as diverse as lavender, Christmas trees, ever-bearing strawberries, summer-bearing raspberries. The time of fruit production actually determines when you put the nitrogen on. So these differences really matter. And we try and cover these all these options. For any perennials, we ask whether they're already established and whether they're yet to be planted. That's a huge opportunity if you haven't planted yet to mix certain nutrients into the soil that you can't really after planting because there's roots in the way, right? So if you can influence the future rooting zone, that's the time to do it. Things like limestone, things like more immobile nutrients like phosphorus or potassium, you can really add in larger quantities that after planting are a bit hard to get into the soil. You're really looking at surface applications. For annuals, we also ask what the soil source is. We have many producers who source local soil mixes, maybe for raised beds instead of growing in in-ground soils. And these often have very different characteristics than what you might see for typical Western Washington soils. So just kind of knowing that this is why we're seeing this mix of characteristics rather than it's because of past nutrient management can be really helpful in understanding kind of where they're coming from. So how do we get all this information from people without overwhelming them and ourselves? There are a lot of ways to do this, but like many in the conservation district world, we rely on smart sheets. So smart sheets is kind of like an online Excel that has where spreadsheets can be linked to online forms, and so it's been really great for this. You could also probably use Google Forms, and there's other software as well. Our online form, if you look at all the options, is massive. But thanks to something in Smartsheets called conditional logic or form logic, the options our tester sees while filling out the forms are only the ones we really want them to see or they need to see. So here you can see on the right, there's 3 screenshots of somebody choosing vegetables, lawn, and blueberries. And depending on what choice they chose, only the questions we really need to get answers from them appear. I think another major limitation for technical service providers is time. How do we have the time to provide this service at the scale that we do? That's a great question. And I'll just point out we're in the middle of March. So this is the middle of probably our busiest time of year. And the graph here, this is from actually 2 years ago, but middle of March was quite busy. And this isn't even the full, I don't do this full time. And so it can add up quite quickly. And this was an early challenge that I realized when I took over TCD's program. And it's one that we've largely addressed through automation of a lot of this work, which I'll kind of cover throughout the rest of this presentation. So TCD's automate, or what you see on the screen is kind of a rough view of TCD's automated workflow. And some of this has just changed in the past month or so. So it's very much a work in progress, but a very productive one that's continually upgraded. This might look like a lot to do, but the parts that I really have to actively touch base on are fairly quick, and they're all shown here in green. And you'll see some of those more in depth here in a second. So we start out by gathering input from our online input form. You saw just a few screenshots of that. You can even go to thurstoncd.com and look at it for yourself. And that feeds into an online spreadsheet or smart sheet. And that feeds into some Python scripts that I use to interpret the data. On the other end, we have our lab portal where we download the lab results in both PDF form and in a spreadsheet form. And then that's accessed by the Python script. And this does the bulk of the work, processing the soils data in context of the management choices. So it's pulling in both the soils data and then the management choices and preferences and outputting that information into a spreadsheet. That script output comes in the form of a spreadsheet, and that feeds into Adobe InDesign, which is an amazing program for automating report writing and other documents. And then when I'm in InDesign, I run scripts in InDesign that then does its formatting magic and outputs a pretty much almost complete report. And I would say the last step is reviewing the draft template. This one is huge. I think one of the key benefits of this is it saves so much time that even though a lot of this seems really mechanical and automated, right? It's actually creating more time for me to personalize reports. Look at what our standard recommendation would be, look at it and see, does this make sense? Did this person test with us in the past? Let me go in here and customize this. So it's actually freed up the amount of time I have to really put a personal touch on it and keep track of the nutrient management programs of the folks who test with us. So to go back to the Python script, each crop and plant type requires its own interpretive script. I think my first one was lawns, then vegetables, then flowers, and I've still been expanding. I haven't done them all. But here on the right, you can kind of see an example of the many if-then statements that are in the code. And so the code primarily takes into account the soil testing data, but also, even pulls the current day. So if you run this script in winter or in spring, or in summer, you'll get different output that's seasonally appropriate. And then, of course, through Smartsheets, it pulls in information on the crop type, fertilizer rate, and management preferences. So it's taking in that important information into account. So I have a short video that shows what this looks like in action, and I hope it shows through all right. So the first step is to run the code. And this little kind of prompt here, you'll see some text appear shortly. This is talking to our Smartsheets directly, and you can see there are 4 samples. This is the vegetables code, so there are 4 vegetable soil tests that are waiting to be written. I type this little number next to the one that I want to write, so 839 next to my name. It's going to ask me for the lab number. This is just pointing to the data. And then it's asking for the row number. Sometimes there are multiple samples on a report. And then there's some custom scenarios where I can write in a number. We don't have any of those, so I'll put a 0, and then it's done. Just in a flash of a second, it's already done all the work, and it tells me to open Adobe InDesign. So the Adobe InDesign templates, before I show you exactly what that looks like, you can kind of see what the general format of our reports looks like. Here on the left, it looks quite empty. There's these little kind of placeholders in the text. And on the right is an example of when that's filled in. And we really customize them by crop type. So you see vegetables here on the right. There's a vegetable photo in the banner, and all the customized information filled in. Flowers look slightly different. For pastures, we even have some additional pages that are retained and are pasture specific, because you really need to change the nitrogen application rate to meet your forage production. So we really try to create guidance that's really helpful, but also crop specific. And then we also have specialized soil pH bars, a little bit more on that later. So here's a video of the Adobe InDesign, what things look like on the Adobe InDesign. So we have a number of pages. You can see 1 through 8 here on the right. So we have a page for the narrative. This one's the results page, which has the pH bar on it. You've got micronutrients. This is deleted if they've just done a basic test. Some folks include a micronutrient panel. This next page is pasture specific. It's only retained if you're running a pasture test. So all you have to do is go to the scripts panel, right click it, and run the script. And then wait. It takes about 20 to 30 seconds. It's not quite as instant as the Python code, but I'm gonna zip ahead here. And any second now, the information that it's drawing from will appear. There we go. So there's auto-generated narrative. Even that's automated, but very often customized, of course. And you can see in the upper right, there's the sample ID, the date of the test. So they have that for future reference, their preferences, their address for reference. And I'm going to show what the later pages look like. So we're going to look at, at this stage, yeah, you can, as I mentioned, you can type additional text in the narrative, delete, there's just opportunities to edit at this stage. And then here's the results page. Any nutrient where there's an action item, that's always highlighted in yellow to point it out. On the next page, because we did, skip ahead. Because we did test for micronutrients, that's shown here. So you see the interpretation for that. And then finally, there's the recommended fertilizers page. So many people are taking this page into farm stores and able to point to the fertilizers that they need. And then the final page is just a resource page to help them understand NPK ratings, fertilizer concentrations, really kind of demystify some of the things they might see in the back of a fertilizer bag if they're not used to that. And then the manual review, and I mentioned this, like automation's a tool, but it's not a complete solution or even the end goal. Every single report is reviewed in close detail. But the time savings allowed by this processing has really allowed for more opportunities to personalize and customize. One of my favorite things to do is look back in time and see the progression of someone's soil over time. Nutrient management is always best done as a long-term process. And one of the most rewarding things as a technical service provider is see them make progress and really engage with that. So this is just another quick review of what the output PDF looks like. It's a little bit more dialed in, or a little bit sharper looking when you export it than in InDesign. But you have your first page here with the narrative, second page with the results, micronutrients, and recommended fertilizers. And then again, that resource page at the end. As I mentioned, many cooperators who've been testing for multiple years regularly ask follow-up questions. And these questions show real engagement with the soils data and with nutrient management. Some of them are really great questions, things like, looking at seasonal variation in pH, kind of stumping and me as well, and then realizing that that's due to soil texture and the time of when that was sampled. People, noticing patterns like, hey, boron's always low when I test this time of year. What does buffer index mean? You're talking about soil pH, but I'm noticing this extra number here and it's different for my samples. And one thing I'd say too is there's a bit of a virtuous cycle in this. Automation was something I first started looking into over a year and a half ago, and it's resulted in a lot of time savings. Automation really helps speed up interpretive report writing, which really allows for additional script development and automation, which of course increases the overall level of automation in the process. So it's really kind of been a reward, self-rewarding process, and also allows for adaptive optimization of these processes over time. So there are certain situations we run into, things like high sodium, high nitrates, some unusual alkaline soil pH, we're typically acidic here west of the Cascades, or even elevated soluble salts, which I'll talk about later. And so sometimes when I'm automating things and I'll get unusual results that'll pop up in the output. I'll say, I'll kind of flag it, and then I'm able to integrate those new situations. So it's really allowed me to make the code a little bit more comprehensive. One great thing with using a script approach as well is you can develop visual ways to represent data. If you're using a script-based approach, this can be done automatically. And I really appreciate this because it allows people to interact with data in a visual way. So it's not just all numbers. I don't mind looking at numbers, but when you are able to make things visual, it really can help many people, and we've gotten a lot of positive feedback. So here on the right, you can see different soil pH bars for 3 different soil crop types. And of course, those preferred pH ranges are all different because crops are different and diverse. And so what we do is we point out the current soil pH and then use colors and shading to indicate kind of where that target is. Thanks to a Python graphing library, I was also able to bring in things like the classic soil texture triangle. We had one person who was using a number of soil mixes and represented the results. I was able to represent those results visually using this code. So he was interested in using some soil mixes or some perennials, and it turned out they were all kind of sandy loams. So we were able to have a good conversation about just the water holding capacity, what that might mean for his goals. Next, I'm particularly excited about using things like representing things like cation exchange capacity in soil test reports. This is just an auto-generated pie chart showing how much of the cation exchange capacity is occupied by different nutrients. This is something we typically don't dive into most reports because it's a little bit more advanced, and we tend to more interpret that on our end, usually for things like calcium and magnesium, where you're looking at CEC thresholds. However, I'd really like to bring it in because I think it's powerful to show some things like the benefits of raising soil pH. Like adding soil pH is going to reduce the amount of acidity in the soil and the amount of CEC that's occupied by that. So something for the future that I'm fascinated by. Everything that I presented is simply one way to work, some sort of workflow to work smarter rather than harder. There are others, and so there's some less technically involved options that can result in good quality output. That can result in significant time savings and also eliminate a lot of the risk of human error. If you've ever done calculations by hand, you can make errors. And things like this Excel spreadsheet I put together in spring of 2021 was really pivotal in helping me save a lot of time calculating fertilizer amounts. So here, let's say you need 100 pounds of potash potassium fertilizer for your crop. You just add 100 in this box, and on the next page, it auto calculates for 3 common fertilizer types, both the pounds and ounces you would need on an acre basis per 1,000 square foot or per 100 square foot. And you can also work in things like split applications, which are important for certain crop types like pasture. So you can make sure you're adding equal sub applications. There's and like I said, there's a lot of different tools you can use. So if you're a technical service provider and want to build your own workflow, you can kind of mix and match and see what would fit, or really work with what you have access to. So we use smart sheets for cooperator input, but you can use Google Forms, maybe even Survey 123. For report processing, if you're taking a code approach, you could use Python or even R, which JD will be presenting on in the series. I'm really excited to attend that. And then report generation, you can use R, you can use Adobe InDesign. Just a few months ago, we were using Publisher, and I just switched this all over to InDesign in the past 2 months. Or Microsoft Word, just developing standardized templates can really help you provide like crop specific guidance in a way where you're not recreating the wheel each time. Another great benefit, I would say, of the more scripted approach is you can aggregate your data and look at it and look at the whole picture to visualize trends. We have 7 years of soils data, and as a data nerd, I really enjoy kind of zooming out and looking at this data in aggregate and asking questions of it, looking at what trends there are in soils data across the county. So here on right, there's just a table looking at correlations between certain soil factors. One strong trend that's come out and that I think has been really helpful in understanding some of the benefits of liming is adding limestone to raise soil pH is just the relationship between that and cation exchange capacity. So there's a clear correlation with higher soil pH and cation exchange capacity. Correlation isn't causation, but from what I understand from soil science concepts, I kind of suspect this is likely like pH dependent cation exchange capacity that's being freed up. So, and we have many people who work with us over multiple years, and so I've been looking at their results to see if that's holding true to their scenarios or in their results. Oh, that's my way. Another example is phosphorus. We have really high phosphorus levels in Thurston County. This is, in many counties in Puget Sound have this as well. We have a lot of phosphorus produced from kind of livestock. We have a little bit more livestock than we have cropland to accommodate the phosphorus that's produced. And so this imbalance has led to a lot of buildup over time. And so this is really important, especially when considering things like sources of organic nitrogen, especially at a larger scale. Manure is often the cheapest and most readily available source of organic nitrogen, but if phosphorus is already high, it might not be the best option. Another, I want to go over some challenges. I've talked a lot about process, but I want to talk about some kind of on the ground common situations that we run into in Thurston County, and that might be common in Western Washington or even in Eastern Washington as well, or Central Washington. And so I mentioned we offer crop specific guidance, but we often run into folks where people are interplanting many different types of plants in close proximity. And so they're really looking for one size kind of fits all guidance for these really complex interplantings. I think they're trying to increase diversity, which I think is great. But unfortunately, some of these mixes are plants with mutually exclusive soil needs. A good example here, you can see in the bottom is a soil pH chart. You see the ideal soil pH range for high bush blueberries on the left, and then the soil pH range for lavender. And so if you'd planted these right next to each other, it'd be very difficult to create a kind of easy way to manage that. You could even easily swap out lavender with backyard vegetables and many of the soil mixes people plant in there. And so things like dying blueberries are kind of a common challenge that we often find ourselves working with. Another good example would be fruit trees and vegetables. Vegetables often need certain nutrients at a much higher rate than fruit trees, where you definitely want to avoid over application of nitrogen for fruit quality reasons. Thirsting. Oh, all right. Another challenge is kind of the many niche or uncommon crop or plant types. Thurston County is full of agricultural experimenters, and it's something I love about working here. I'm one of them, and I joke that I have half of these growing in my own backyard. But one of the hardest things to do sometimes is say, I'm not sure, or I don't know, or we have incomplete guidance for what the nutrient needs are. And so in those situations, I really have to kind of set expectations about what we can realistically do. And in these situations, I try to provide what I can, and also ask that they let me know how these crops are doing for them, what they're adding, and try to learn from their experiences. And third, the third situation we commonly encounter is elevated nutrient levels and kind of alkaline soil pH. So usually the 2 to 4 feet of rainfall that we get in Thurston County during the winter generally rinses a lot of the water soluble nutrients, things like nitrate, nitrogen from the soil. And I'm sorry, that's the next slide. Sorry. So in greenhouses and high tunnels, we often have nutrient buildup. So because you don't have that 2 to 4 feet of rainfall leaching out any extra nitrate, nitrogen in the soil, it can build up over time. And so many times a soil test will come through, it'll have extremely high nitrates and sulfates, elevated soluble salts as well, often above 1 millimoles per centimeter. That's going to start affecting sensitive plants like lettuce, even higher, can affect most other vegetables. In this case, this is 4.1, so quite high, and sometimes a high boron and sodium. And so these require really special nutrient management to get the nutrient levels back down. It's kind of, like I say, it's like kind of creating a little bit of a desert in what's otherwise a very rainy climate. So a very different type of nutrient management scenario. And then finally, what I skipped ahead to is soil mixes. So another common challenge is that many soil mixes are generated locally. Many people want to make sure they're starting off with good soil, and so they go to purchase a soil mix. And I think this is where this kind of crop specific choice is really important, because each crop has its own needs. These mixes are often created for vegetables, which like more of a neutral soil pH, slightly acidic to even slightly alkaline. And so many people will buy these, and they often have some very unusual characteristics compared to typical soils in Western Washington, where we tend to have more acidic soil pH. And so, planting a blueberry in this might and has actually led to decline, stunting, or even death of the blueberries. So kind of in these soil mixes, this is something we've asked about, just to make sure that if it is a soil mix, we understand it's not from past nutrient, wasn't past application of some amendment, things like wood ash or I don't know, calcium hydroxide or something unusual, but really that's where they're starting from. So yeah, this is just one thing we keep an eye out for. And then I also wanted to give a short timeline of Thurston CD's soil testing program, or at least my time with it. I began managing the program in October 2020. And in many ways, Thurston's CD soil testing program has and continues to be a work in progress. There's still a lot that I'm working on. This is an active work in progress. And I think maybe as you've seen these slides, you think, oh, maybe you could do that, or maybe you could do that. And there's just so many ways where we could develop, really meet the needs of the community. And so I'm kind of really excited for the ability to really develop this over time. I mentioned the work with InDesign was just in the past few months. Previously, we'd used Microsoft Publisher. So a lot of this work you're seeing was just done just weeks ago. But yeah, we've come a long way, and I hope that some of what I've done here is useful for you listening now. Maybe it kind of inspire you to think, hey, maybe we could use this or use this resource that we have, and maybe recreate some of this process, so we can kind of expand what we can do as technical service providers, what we can do to the public. And kind of reaching the insights here, but I'd like to end on kind of one note where I'd really like to develop future work. I really am interested in incorporating more of a biological approach. I think this is focusing on the chemical side of things, but there's really a complementary role for the biological. Many things in the biological end have a chemical mirror to it, and I get a lot of questions about the biological end. For instance, somebody maybe grew a cover crop of a legume, and they're curious about what the nitrogen contribution of that might be, and if that could offset fertilizer. Here on the right, you can see this is a screenshot from an OSU publication called Estimating Plant Available Nitrogen from Cover Crops. And it's a great one, and it has a lot of calculations and a lot of math, which kind of made my ears perk up, because that's exactly the kind of thing that with soil testing we've been able to handle with some degree of automation. And so I wonder if there's ways to incorporate calculations like this. If you know how much weight of maybe a clover cover crop that you have, could that be something that we could integrate? So what could we do in this area? So this is something I'm excited to explore. And then with discussions around soil health, my mind goes to nutrient cycling in a bigger sense as well. I think, the approach in our reports is often looking at what's low and then adding it back in, right? But we know that with agricultural systems, it's not just arrow in, arrow out. we've got cycles. And so, I just covered cover crops, but what about nutrients returned through crop residues or through composting? I think one of the big questions that, or the way I see it, is that in many ways I'm interested in bringing a quantitative accounting of these really qualitatively complex things like nutrient cycling. And are there ways that we can do that to where it's not too complicated and we can make that actionable? So this is one question that I've really put a lot of thought into, and it's kind of maybe more in the distant future, but kind of one of the goals. And maybe a good thought for my last slide. So that concludes my presentation. Thank you so much for attending, and I think this might be a great time to start taking some questions. I see there's a number in the chat.
Yeah, Adam, thank you so much. That was awesome. And you have quite a number of questions. So I'll just kind of order them for you and we'll get started. So the first one is if you have a preferred lab you like to run your soil analysis through.
Sure, yeah. Yeah, in terms of lab preference, I mean, we've worked with 2 labs, A&L and Midwest. I think mostly it's just, making sure the price and the turnaround times are good. I would hesitate to make a recommendation for one commercial company over another as a public employee, but those are the 2 that we've worked with. There are many other labs in the area that you can work with as well. So I would just say, if you're trying to make that decision, it's always good to shop around and see what's out there.
Awesome. And somebody asked if you would be willing to share resources from your workflow, like possibly the Python code or your Adobe templates.
Yeah, so that's one thing that's definitely more of a work in progress. So I would say it's not quite in a state where it'd be easily shareable. I'd also maybe want to have a conversation, because it is so Thurston specific. Where are you going to be using it? Are there ways it can be modified? I think there are some resources that I think eventually I definitely want to get it to a place where it's easily shareable. There's a lot of components to it as well. So gosh, I wish it was like a software, like a exe file, and I could just send it to you as an attachment. But there are other resources that I could probably share in the short term. One of them would be the Excel spreadsheet, where I have like basically a tab for each nutrient. And so if you're going through and you need 100 pounds of phosphorus per acre, and 1 pound of boron per acre, I think that one can realize a lot of time savings, and it's a lot less complicated to set up. So. And also all the extension publications, I could put together like a resource list of where I've turned to.
Yeah, and Molly has been sharing the resources you've referenced in the reference chat, or sorry, the resources tab of this Zoom portal, but she'll also send it out afterwards. And it sounds like for the person interested in the scripts and the workflow resources, perhaps get in touch with Adam directly. So another question somebody had is, and you touched on this a little bit about biological soil testing, but there's a number of questions coming in about kind of the future direction of either biological soil testing or integrating remote sensed data or infrared spectroscopy. Maybe you could kind of talk about emerging indicators and how you may incorporate them.
Yeah, no, I'm really excited about those. I think kind of my background's in research, and so I really look to the researchers to provide a lot of that work. And so I would say we're not doing any biological soil testing now. I do think I try to incorporate biological aspects as much as possible, especially from the nutrient management side of things like keeping your phosphorus well balanced, so your mycorrhizae are happy. There seems to be understanding that having too high is not good for that. I would say as soon as there's actionable guidance out there and there's testing that could easily point to those factors, I'm going to be integrating that as soon as I see it. Right now, it's a bit difficult to get. It seems like we're still working our way to that point. So yeah, very much I would love to, but I don't quite have those resources yet.
Yeah, thanks. And for people who maybe don't know, this is a series. So today we're talking about chemical indicators. Next week, we'll be talking about biological indicators, specifically plant pathogen indicators. So stay tuned, because we may repeat this series and do more biological series webinars as well. So Adam, someone wanted to talk to you about the phosphorus tests used in Western Washington. I know there's kind of a lot of talk about Olson versus Bray, and someone said that having looked at thousands of these results, they vary over 200% from one test to the next. And maybe you could talk a bit about that.
Sure. Yeah. That's one thing I have seen a lot of variation in some of the phosphorus from year to year, even in my own soil testing. I remember going from like 200 to 80 the next year and thinking like, what did I grow that used that much phosphorus? So there definitely is a lot of variation. What I would say is, at least more in applied sense, many places we work with or many locations have really high phosphorus. It's kind of often, I would say there's almost like a bimodal distribution of very, very low 1 to 2 to 3 parts per million kind of native soils that haven't had an agricultural past, and then something that's really high. So I'd say even with that variation, it often thankfully doesn't make it too difficult to see that variation on the upper end. If you need to have a target of 50 parts per million and your soil tests are varying between 90 and 140, you're probably in a good territory despite that high level of the variation. Interestingly, yeah, we've used the Olson test because some of the soil mixes are alkaline. So it's an interesting one where we're using a test that's not quite too commonly used in Western Washington, but soil pH is as high as 8.2. So we also use that one as well, but a little less commonly. So
Thanks. And then a few more questions about kind of emerging amendments. So someone wanted to know if and how you make recommendations on sort of non-standard additions like biochar or mycorrhizal fungal amendments, humic acids, anything like that.
yeah, and we get asked about those a lot, and I would say once those become standardized, then I could make those recommendations. I think there's a lot of potential in a lot of those, and I think people are interested in application rates, types. I think people would be really happy if I made a recommendation. My fear is that I recommend the wrong thing, and that would do those potential amendments a disservice, right? Because many people coming to us are like, oh, I just want to have a really good garden, and if I say, oh, put a bunch of biochar on, and then it's the wrong type of biochar, maybe it adheres too much to the soil nutrients, then that's doing them a disservice, and also biochar, which I think has tons of potential. So I'm really, every time there's a new extension publication out on biochar, I'm reading through it and getting excited about the emerging research. So yeah, great question, that one that frequently gets asked.
Yeah, I think I was really excited to see your talk focus a little bit on pH because there are so many emerging indicators and kind of new flashy biological tests you could take. And I think sometimes it kind of it makes people look the other way from tests that are just standard and maybe old school and perhaps not as exciting. But pH, of course, is incredibly important to manage in soils for soil health and crop production. So I was wondering if you could talk a little bit about pH in your program and kind of how you think about it, how you talk to your farmers about it.
Yeah, it's a huge one. And I would say, being in Western Washington, we typically have a generally like slightly to moderate acidic background of soil pH. Anything I've seen things a little bit on like 4.8, 4.9 in certain kind of wetland, kind of lowland situations to around like 6.0. And so one of the most common recommendations that we're making is adding limestone, right? Because a lot of people are growing crops that really are happier in the slightly acidic to neutral range, things like vegetables, things like mini fruit trees. And we know that some of the availability is highest in that kind of more moderate range. When things are really acidic, you have tie up of certain nutrients. That being said, and this is a great thing when I talk to farmers, I think many of them think, oh, so acidic soil equals bad. I'm like, not really. If you're growing a blueberry, it's perfect. I think many people think, oh, so the blueberry, the acidic soils are bad. I'm going to go get some soil from the outside and plant my plants in that. And I'm like, actually, no, our ground is really great for things like blueberries, things like lingonberries, huckleberries. Many people have questions about rhododendrons and azaleas. And so there's a whole, set of crops that love acid soils. So I would say this really ties into the diverse solutions for diverse soils and diverse crops. It's really knowing what your crop likes and making or plant type and making that fit. So, and when I think of soil health, I think if you have happy plants, you have strong living roots. It kind of it ties all together. So
Awesome, thanks. So now we have a set of questions, less about the soil health metrics themselves, but about sort of the outreach and extension piece of this.
Okay.
Someone wanted to know if you've gotten feedback on the report and the graphics and whether or not those are different or if they're received differently between the farmers and the home gardeners. Are there groups that have one preference or another for the graphics and the metrics that you're presenting?
I actually haven't I've gotten feedback, but I haven't noticed a difference between the two. I think one of the things I'm really interested in doing is doing like a survey and asking, and especially we do ask, based on rate, say, okay, great. Are you a backyard gardener? Are you, larger scale farmer, smaller scale farmer? Getting some feedback on these new templates. Many of these, we're kind of phasing them in. So I think once we've maybe phased a lot of this in kind of more, then maybe providing that information. We also, we've had, I think, two sets of past templates. We've really kind of worked in the more continual feedback that we've received over time. So I think one of the universals is the visuals are really helpful. In fact, there's a great question here about red and green and color blindness. That's one reason why we've added text to say optimal, not optimal, focusing on hues. So some of the differences are still showing up. And I think I'd probably do a better job there as well. But yeah, just trying to develop more visual techniques, I think, is a universally appreciated thing. So not the numbers are bad. I love tables of numbers. So I think they're beautiful, but yes.
So when I first heard about your project, and one of the reasons that we asked you to be here today is because the number of producers you're reaching is quite impressive. And like you referenced, capacity is always an issue. And so it can be hard to reach this many producers. And I was wondering if you could maybe give your thoughts or your recommendations for other technical assistance providers or other conservation districts who may be interested in doing something similar, even if they're starting from scratch. How do they use data to reach more people in their communities?
Yeah, my hope would maybe be, finding ways to work smarter rather than harder. I think when kind of the first spring soil testing season, because typically people will test in spring for the coming season, or they'll test in fall, kind of at the end of season. And so there were kind of these two big bumps. And the first one, I remember kind of running out of scratch paper. This is full of unit multipliers. I'm like, I can do this smarter. And so, using Excel and just formulas, I was able to create kind of the sheet that I showed there. I think just finding ways to economize and that the more rote aspects of conversion, finding ways to rely on those and create tools can really make your time as a technical service provider a lot more effective in providing as much guidance as we can.
I think that's all of the questions I'm seeing in the chat. And so possibly we can just end with a slightly personal note. And I would
Okay.
love to hear from you sort of why soils and what about this work interests you and why are you doing it?
Yeah, soils is why I got into crop science, which led to GIS, which led to Python, which led back to soils. I was fascinated by world phosphorus supplies, and actually went into crop science at WSU, kind of ended up in Dr. Kevin Murphy's lab because I was interested in perennial grains. And I think I was really fascinated with this idea of nutrient cycling. I think every time when I was in the Evergreen program, I kept asking like, oh, okay, where's your nutrient inputs and nutrient outputs? And I'd create these little charts and try and put together where the inputs and outputs were coming and then going out. And so I think just kind of following that passion led me to crop science and then finding ways to interact with that in a data sense. So for me, it's all tied together. And that's why I really appreciate like series like this where you're approaching it from different angles, because kind of an interdisciplinary approach gives you a way to look at it that is just so much more rich and holistic and comprehensive. So
Awesome. Well, thank you so much, Adam. I know Molly has put a ton of resources in the chat, and she'll also follow up with an email. This presentation will be recorded and added to the Washington Soil Health Initiative YouTube library, and you'll get a link to that as well. And finally, it looks like Molly put Adam's email address in the chat, so Adam can continue to be a resource for all of us. Thank you so much for your time today.